Welcome to lesson number 3 from New Jersey. This is about ray diagrams with mirrors. We're going to split it up in two. First is going to be ray diagrams with convex mirrors because those are the easiest. I wrote down the rules already, so you can write it down. I'm going to read it out loud, and if I go too fast, pause it, write it down. Okay, ray diagrams with mirrors are almost exactly the same as ray diagrams with lenses. So you start at the top of the object, top of the arrow, and you still draw a horizontal line to the mirror. But instead of with the lens where you bend it through the lens, with the mirror, you reflect it. You either reflect it towards the focal point if you have a concave mirror, or away from the focal point if you have a convex mirror. I can't do that with my hands. Away from the focal point if you have a convex mirror. And ray number 2 is to the center of the mirror. And then, unlike a lens where it just goes straight through the lens, with a mirror, in the middle of the mirror, either kind of mirror, in the middle it's basically flat, so it reflects at the same angle it came in at. So this is much easier to see, much easier to understand, if I just show you an example or two. I'm going to pause for a second, so you can write it down. Okay, so example, convex mirrors. So I'm going to start with my convex mirror. Convex means stick out in the middle. This furry end is a fuzzy end, whatever, is the part that's not reflective. So we're over here in the reflective side. Can you draw it backwards? Of course. And sometimes you get a problem where they draw it the other way and they put the object over here. Just depends on whether you like to draw from left to right or from right to left. Okay, so we're going to do a focal point, and let's do one. Let's stick with our 6 and 3. Sure, why not? Focal point is -3 centimeters. The object is 6 centimeters away from the mirror. 1, 2, 3, 4, 5, 6. Distance of object is, oops, that's not 6. 6 centimeters. Okay, and the focal point is -3. 1, 2, 3. Notice, the focal point is negative, means it's behind the mirror. Also notice with mirrors, it's easier than lenses. The focal point is always in the circle. So if it's pointing this way, it's in the circle. If it's pointing that way, it's in the circle. It's actually half the radius, and I'm going to show you that some other time when I feel like it, but not right now, because I'm too lazy. Okay, so start with the first line. You start at the top of the arrow. Oops, I lost my pen. That's all right. Start at the top of the arrow. Go to the mirror. Now this one is going to reflect away from the focal point, because the focal point is inside the mirror. It's not a real focal point. So what we're going to do is draw a dotted line, so I know dotted line from the focal point to where the light hit the mirror. And then it reflects away. That way I can tell exactly which direction is away from the focal point. I draw the dotted lines already. Ray number 2 starts at the top, goes to the middle of the mirror, and then reflects at basically the same arrow. Does everyone see that at this point it's basically vertical, the mirror? So it reflects at basically the same arrow. So this angle is the same as this angle. Is it exactly the same? Well, no, I didn't use a protractor, didn't use a ruler. Man, I am losing my pens all the time today. That's all right. I forgive myself again. So, yes, it's basically the same. As long as you make it basically the same, this angle and this angle, you're good. So these two rays, they go away from each other. So what you want to do is back up. This one's already been backed up. You could keep on going if you want to, but you don't need to. This one, we're going to start at the arrow and go backwards from there. And they meet right here. So it looks like you have an image right there, right at 2 centimeters. And we'll do the math once again. The math for mirrors is exactly the same as the math for lenses. Exactly. So since I keep on using the same numbers, my life is really easy. 1 over the distance of the image is 1 over the focal length minus 1 over the distance, which is -2 over 6 minus 1 over 6, -3 over 6. -1 over 2, so di is negative 2 centimeters. And once again, if the distance went from 6 to 2, then the height went down by a factor of 3. If the distance goes down by a factor of 3, the height goes down also by a factor of 3. Now, that's it. That's all I was going to say. Some of the problems, they'll give you the height. They'll say this has a height of 9 centimeters, and then inside it, if it's 3 times smaller, it'll have a height of 3 centimeters. Don't stop recording, because I want to talk about flat mirrors for a moment. Flat mirrors. Flat mirrors are actually kind of an example of either convex or concave mirrors, but we're going to do it in this section. Flat mirrors. Now, very rarely will you be asked to do ray diagrams for flat mirrors, but sometimes it's kind of interesting to see it in my book. So we're going to do it. Flat mirror, let's say you have an object 6 centimeters away. You're standing in front of a mirror 6 centimeters in front of the mirror. We're going to do it exactly the same as before. One line horizontal to the mirror. But now there's no focal point. So it doesn't reflect away from the focal point. It doesn't reflect to the focal point. It reflects horizontally. The mirror is flat, so it just reflects right back and just keeps on going. So the light from the top of your head, some of it that's going horizontal, just reflects straight back. And then the next one goes down to here and then reflects at the same angle. So these two arrows are going away from each other. So we're going to backtrack. This one, back horizontally, or to a focal point at infinity. Either one is fine. This one, backtrack, and you end up with an image, same height, same distance to the mirror. Let me look at the equation and you'll see how that works. You got 1 over the distance of the image equals 1 over the focal length minus 1 over the distance of the object. The focal length is infinity. 1 over infinity is 0. So in this case, the distance of the image is negative the distance of the object. Negative because it's virtual. If you put film there, it won't develop. The light isn't actually going behind the mirror. It looks like your image is behind the mirror. So this distance, this is 6 centimeters. I like 6 for some reason. This is also 6 centimeters. Okay, that is the end of my lesson. The next time I'll talk about concave mirrors.